Hello, my name is Dylan Voss, and today I'm going to be talking about farm nutrient capture and recycling. Nutrient river pollution occurs when excess farm fertilizer washes off fields into rivers and streams. This causes large algae blooms that feed off the excess nutrients. Not only do these blooms block out sunlight for other river life, but as they die and decompose, they consume oxygen in the water, which starves the other river life for oxygen. They also plug fish gills. Certain species of algae blooms are toxic and have been known to cause cancer in humans. In addition to these health and environmental issues, algae also have an economic impact in the fishing industry because they kill off or poison the fish. So how do we fix this problem? My team and I wrestled with various possible solutions such as on-site nutrient recycling pumps, hands-free nutrient catchers, and high-volume filtration systems. During our research, we discovered that the solution to the problem may lie within the problem itself. We realized that we can use controlled algae cultures on farm to capture the excess runoff nutrients before they enter waterways, starving the algae blooms downstream. This shift in location of the algae growth will save river life downstream. As the algae culture grows, excess algae can be separated from the culture and sprayed back onto the farm fields as fertilizer. Now you may be wondering, wouldn't the introduction of algae cause problems? No, because the algae species used are local to the environment and non-toxic, and a small amount of algae leaking out of containment is good food for fish. In case you're still not convinced, to support our research, we have referenced over 75 articles to ensure that our solution will be effective at solving this problem. A possible implementation for algae-based nutrient capture is via a bioreactor. The algae bioreactor uses a modular system to allow greater expandability for varying sizes of farms. The system consists of a pump that takes in water that has been polluted by farm nutrient runoff. The type of pump used is a peristatic pump due to its energy efficiency and long-term reliability. The water gets transferred to a bioreactor that consists of transparent tubing that allows the algae to grow. The helical pattern of the tubing allows for the agitation of the algae, which increases growth speed. Once the algae have had time to sufficiently develop, the pump intakes more water, which forces the newly developed algae through a separation device. This separates the algae from the water using a water-permeable membrane. The algae captured from this device is nutrient-rich as it contains the exact same chemicals that are used in the fertilizers that are used on farms. These algae can now be sprayed back onto the crop fields as fertilizer. Since the majority of farms and nutrient-carrying streams are in remote areas, a solution which can be effective while requiring no human interference would be very valuable. That is why we explored this solution, which is an all-in-one system which can not only be easily implemented into small streams, but can also capture dead algae and rejuvenate the water while mechanically doing nothing. By utilizing the natural downhill slope of a stream, we can place this specially designed block of concrete which lets water dribble down a series of algae capturing indents while aerating the moving water. At the bottom of the series there is a large holding area for any latent bacteria, followed by an algae blocking overflow curve. The idea is that in the event of heavy rain or unusually high tides, the nutrients would still be captured since there is an area of slow-moving water, which allows the dead algae to sink to the bottom. Under normal circumstances, the water would just overflow past the holding wall, be aerated one last time, and continue downstream with a newly rejuvenated vigor. Once harvest has passed and the streams are low, the system can be cleaned out and prepared for another year of hands-free operation. Overall, this is a cheap and easily maintainable solution for a dangerous problem. The idea of using algae to capture nutrients can also be executed on a large scale. Dedicated algae farms currently exist in the United States. These farms produce biomass which is already being used to produce synthetics, rubbers, human and animal foods, and biodiesel. What if algae farms could also solve the issue of polluted rivers? Here's how that would work. Water from the river would flow into a large lagoon. The size of the lagoon decreases the water flow speed and provides the perfect environment for algae growth. At the end of the lagoon, An algae water separator removes the algae from the lagoon water. This separator is not a new idea. Algae water separators are currently being used in existing algae farms. The algae sludge collected from the separator is then shipped off to be manufactured into useful products, and the clean water is fed back into the river. Why would we use large-scale operations such as this one? Large biomass production facilities can generate big profits from useful products created from algae. Also, algae consumes large amounts of CO2 from the atmosphere, which is also a current problem in need of a solution. Further details on this project can be found in our technical report. On behalf of myself and my team, thank you for watching.